All right, so I did my project on climate and its impact on California ecosystems. California has a latitudinal range of 9.5 degrees. The lower latitudes in the south receive more sunlight due to a higher sun angle and have more consistent day lengths, leading to a higher average temperature. Higher latitudes have a lower sun angle, receiving less sunlight, and seasonal day length varies more, leading to a lower average temperature. Basically, the higher the latitude, the less solar radiation per unit area. Latitude is a control on temperature with a wide range of with a wide latitudinal range. We have a wide range of temperatures here in California. We're a really long state. Topography is another control on temperature. The adiabatic lapse rate, which is the rate in which air is cooled as it rises in elevation. It can be affected by atmospheric conditions, but it's usually 3.5 degrees per 1,000 feet. Inversion layers where temperature rises with elevation are common in areas surrounded by mountains because it restricts airflow. It's pretty common here in California. California also has a large coastline. The ocean helps to regulate temperature. A lot of energy is needed to heat up water more so than land, and water stores a lot of energy. It heats up and cools down slowly, leading to coastal areas having relatively stable temperature. In the diagram here, we have a picture of the Davidson Current, which forms in the wintertime. It brings warm water back up north, helping to regulate temperature. Precipitation is controlled by seasonal variation in pressure belts affecting storm tracks. When air rises and cools adiabatically, reaching dew point temperatures, moisture condenses, forming clouds, and sometimes we get precipitation if we're lucky. Uh, we have two types of atmospheric lifting: convectional lifting, which is heating of air over land, and orographic lifting, which is when air rises over mountains. On the left, we have a picture of orographic lifting. As the air is forced over the topography, it cools and condenses, allowing for precipitation. It also shows the rain shadow effect, how one side of the mountain is getting more rain than the other side. On the right side, we have a picture of the convectional lifting. Going to California ecosystems, wildfire and drought are two challenges California native species are well adapted to. Facultative summer deciduousness is a unusual adaptation found in California sage scrub communities as well as chaparral. It's they when they go into like hibernation mode in the summer or in times of drought, they drop all their leaves, they look dead. But once they get water, they come back to life. Other drought adaptations include hairy leaves, which reduces transpiration, and it's basically microscopic shade. I think the proper term is woolly leaves. Reduced leaf size reduces surface area, lessening the need for water. Volatiles or terpenes are another adaptation. They're like oily substances. Uh, they don't evaporate as much, and they lessen the need for water. Succulents is another adaptation that's characterized by wide roots, waxy surfaces on leaves, and watery tissue. Ice plant is a very common succulent that most people are familiar with. We have some of the most diverse vegetation in the world due to our topographic range, our latitudinal range, as well as our proximity to the ocean, varying climates, our wide range of soil types, and our wildfire regimes. Out of 6,880 vascular plants, 85% of them are native to California. California is isolated by the Sierra Nevada mountains, which has made our state an ecological island. It's a geographic barrier preventing migration or making it a lot more challenging. And it has caused us to have a high number of endemic species here in California, meaning that these species are found nowhere else. We have over 1,400 endemic species, plant species here in California. Over thousands of years, these plants have developed specific traits to climate and ecosystem conditions. There is worry that with global warming, many of these species will not be able to adapt or migrate fast enough. Here's a picture of California poppies. I think this is like a super bloom. It happens like once every 10 years. These plants, their seeds go dormant in the soil, waiting for just the right conditions when we get rainstorms, and all of a sudden the desert comes to life with wildflowers. Here's some examples of California native plant species. This is California brittlebush, Encilia californica. It's currently in bloom. It will look weedy and dead in the summer with the facultative deciduousness. But I mean, if it's constantly getting watered, it's going to be pretty year round. It's not going to die, or it's not going to look dead. Many native species thrive and need fire. Fire clears competition and adds nutrients to the soil in the form of ash. Some adaptations include deep root systems that allow for rapid regrowth after a fire. Thick bark protects against heat and heat resistant seeds, some that are adapted to break dormancy during wildfire. Here's a picture of mustard. It's invasive here in California. And you can see it's growing so dense that it's outcompeting all the other species. There's no other plants in there. Uh, it doesn't have drought adaptation or fire adaptation. So come summertime, it's going to become fire fuel. But if fire were to come through here, any native species with fire adaptations would likely survive. The ash would provide nutrients for the soil, and less competition would allow native plants to hopefully take over the area. The mustard seeds not being fire adapt or having fire adaptations, they would probably get burned up and die. So fire would be a good way to clear it, but that's a risk for humans. Some other plants are the redwoods, or I'm not going to attempt to say that, but the redwoods are found in along the Sierra Nevada mountains. They're some of the biggest trees in the world. Here's a picture of a car driving through one of them. They have fire adaptations. They have thick bark, 2 to 4 feet thick, which insulate the living tissue from heat. And for germination to occur, seeds must fall in an area that's recently burned with exposed mineral soil. A lot of the times, the forest floor is so rich in organic material that it's actually blocking the seed's access to the soil. So fire comes in and clears it, allowing access to uh, mineral soil. Another plant is called cenotes. It's an interesting plant. It actually encourages fire to clear out competition, and it has seeds that use smoke as an indicator to wake up from dormancy. And this plant has deep roots, so when fire comes and clears out competition, it can easily take over. Its leaves actually produce resin, um, which not only is a water saving adaptation, but it also encourages fire because it's really flammable, and this plant has been known to spontaneously combust in the right conditions. Planting of drought tolerant native plants can help address the water problem we are facing here in California. Increasing green space has also been shown to decrease the urban heat island effect. And native plants are adapted to poor soils and do not need fertilizer. A lot of California native plants are actually nitrogen fixers. And restoration is an efficient way to reduce carbon levels worldwide. It's a lot more cost effective than any type of engineered carbon sequestration project.